Hello student, welcome back to the one more session of computer networking and security. This is Vasant Naik from Canara Engineering College. In the previous session, I had discussed about private key, that is symmetric key encryption technique, and asymmetric key, that is public key encryption techniques. I have also told about what is the difference between a private key symmetric encryption and asymmetric key symmetric encryption. Let's recall once again some of the points. The private key encryption or symmetric key encryption technique is the one where sender and receiver make use of the same key. That the key is called a shared key. The key will be shared between sender and receiver. In asymmetric or public key encryption, sender and receiver will use a pair of key that is called as public key and private key. Public key and private key. That is, sender and receiver will use two keys here. So that is a difference between major difference between symmetric key encryption and asymmetric key encryption. Now in this class today we will see the related algorithm of symmetric key encryption. Now the one major problem of symmetric key encryption is the key distribution. For example, consider if there are 5 users, then symmetric key system requires every pair of users to share a separate key. If there are 5 users, then the total number of keys are required is given by this formula, that is n into n minus 1 divided by 2. If n is 5, then 5 into 4 by 2, that is 10 keys are required, and here you see these edges represent the keys. Edges represent the keys like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 keys are required. If the 5 users are there, 10 keys are required. So the number of requirement of the keys increases as the number of user increases. So that is the one more disadvantage of key distribution by means of key distribution in the case of symmetric key encryption technique. And what are the solution for this one we will discuss in the coming session. Now today we will proceed to the one of the important algorithm that is called as data encryption standard, that is the thing but a symmetric key encryption technique. So the data encryption standard or DES was developed by IBM in 1970. This was the oldest algorithm. Still it is used in cryptographic encryption technique. The main concept of this algorithm is it makes use of a shared key. So this algorithm is also known as data encryption algorithm, DEA. It is a block cipher. It is a block cipher. So while explaining the cipher, I have told you in my previous session, there are two types of ciphers are there. One is called as a stream cipher, other one is called as a block cipher. Now what is the difference between the stream cipher and the block cipher? Suppose this is my stream cipher block. If I take this is my stream cipher block, and this is the input, that is the message. This is the input or message or plain text, and this is the output, that is nothing but cipher text. This is the output, nothing but cipher text. So, and this make use of a shared key. Now stream cipher takes the data, stream of data bits like 10, 10, 11, 0, 0, 0 and continuously encrypt it, and the output will be also stream of encrypted data bits, stream of encrypted data bits. So normally this contains pseudo random generator which makes use of the key, and which makes use of an exclusive OR gate. The output of the pseudo random generator is connected to the exclusive OR gate, and the other end of the exclusive OR gate is connected to the stream of bits. So which will generate the ciphertext. So here the encryption takes place by bit by bit. stream of bits continuously moves and the ciphertext in terms of stream of bits continuously provided. This is the technique used for a stream cipher. But in case of block cipher, we have a data block. So initially we have data. Initially the data is divided into different blocks of either different size, depending on varying size. So let me call this block as B1, this is B2, this is B3, this is B4, B5, and suppose if the last block is not in size properly, then additional padding informations are added to make the block to the equal size. And this block cipher will take this block and it will encrypt this block and provide the ciphertext. Block cipher will take this block, so here each block will be fed to the encryption technique, this one function, and output of this one is in terms of block only. So here blockwise encryptions are blockwise data is encrypted. So that is a difference between a block cipher and a stream cipher. So in our case DAS is a block cipher, means it will take the data in terms of blocks. The plain text is a 64 bits in length here, and the key size is 56 bits in length. So key size is 56 bits in length. Now we have three different types of algorithms are there in symmetric encryption key technique. One is data encryption standard, second one is IDEA. In data encryption standard, the block size is 64 bits and the key size is 56 bits. And in IDEA, the block size is 64 bits and the key size is 128 bits. And we have like advanced recent algorithm that is called advanced encryption standard. This is also known as a Rindle crypto system. Here block size normally it is a fixed 256, but it is a variable like 128, 192 or 256 with the variable key size 128, 192 or 256 bits. Now let's understand how DES algorithm works. DES is in the sense like data encryption standard. Here we have 64-bit plain text is there, and we have key of size 56 bit. So initially the plain text is subjected to something called as initial permutation round. In the initial permutation round, we are going to permute the bits in particular order or in random order. After that, the output of the initial permutation is passed to 16 different rounds. I will come to that one. At the end of the 16th round, whatever data bits we get, we will divide it into 32-bit swap. That is, we will divide the 64 data into two equal size, and we will swap that one two equal size and the equal size, and we will swap that one, and finally we will finally we will feed that to reverse initial permutation stage. So in the reverse initial permutation stage, we will follow the reverse process of initial permutation. Whatever we done in the initial permutation, the reverse process of that one will be carried out in RIP, and that will provide a ciphertext of 64-bit. Now we will see how this different round, what are the techniques used in this 16 different types of rounds. So we have here key 56 bit. Initially the key is fed to permutation block. The output of the permutation block are passed into something called as left circular shift. Since this left circular shift is a functional block which will produce key, that is key 1, key 2, key 3 at different round. For example, the left circular shift, the output of the left circular shift at round 1 is given to or is fed to one more functional block PC2. Normally a PC2 is exponential Normally the PC2 is a extension block. What it will do is it will generate 64 bit key from 56 bit key, because you know the plain text size is 64 bit. So in order to provide compatibility between the plain text and key, the key is here 56 bit key, 56 bit. So the 56 bit key is converted into 64 bit key. So at each stage, each round, the particular key is generated, that is the K1, K1, K2, K3, K4, K5 till K16. All these are fed to the round 1. Now what are the technique used in the round 1? We'll see in the next slide what are the technique, what type of technique which will be used in round 1, round 2, etc. So overall processing at the each iteration, that is at the each round, is something like this. Li is equal to Ri minus 1, Ri is equal to Li minus 1 with exclusive OR gate and function of Ri minus 1 and Ki. So let me explain this one by using blackboard. So we have here let me draw this neatly. So triple DES makes use of 3 keys and 3 executions of DES algorithms. That is, you can see here, plain text is encrypted with key 1, decrypted with the key 2, and once again encrypted with the key 3 to generate ciphertext. So here the key size is 56 and we are using 3 keys. We are using totally 3 keys here. So total size of key becomes 168. So the total size of the key is here 168. So you can see here the plain text first encrypted with the key 1, then decrypted with the key 2, then encrypted with the key 3. Here you can follow any format, like you can decrypt first and encrypt next, or encrypt first and decrypt next. But when you recover plain text from the ciphertext, you have to follow the exact reverse procedure. For example, here you can see here the this one output of second stage is encrypted with the key 3. So while decrypting, so in the decryption process, first you have to decrypt with the key 3, then you have to encrypt with the key 2, then you have to decrypt with the key 1. That means you have to exactly follow the reverse process here. So DES had been in use for a long time. The DES replacement of the DES was needed. Why? First of all, DES makes use of 56 bit key. that is not sufficient to provide the security for the present day financial transaction. So in order to overcome this one, they came up with the triple DES. But triple DES makes use of 168-bit key, but it is slower because three times encryption and decryption process will take place. So there was a necessity for the advanced algorithm for encryption or decryption. So in 1997, NIST called this one paper for ciphers, and finally in 2000, Rindal was selected. Rindal, the name of the particular the name of the person who developed this algorithm. So Rindal came up with the advanced encryption standard in October 2000. According to the Rindal proposal, the block length and key length can be independently specified. The block length is 128, 192 or 256, and the key length is also 128, 192 and 256. But AES standard limits the block length into 128 bits, but key length are variable, that is 128, 192 or 256 bits, and easy to implement both in hardware and software, and it is a resistance against all known attacks. That is according to crypt analysis. According to the crypt analysis is nothing but a type of attack on the crypto system. According to the studies based on the crypt analysis, it is found that AES algorithm is strong enough for the present day present day scenario. That is, the hacker with the latest computers, they cannot break this break this key or break this algorithm with in a reasonable amount of time. Now let's see the structure of AES algorithm. AES stands for Advanced Encryption Standard. So this has better security than DES, and the message size is 128 as explained earlier, and key size is variable, and here number of rounds are 10 to 14. So the plain text is formed as a 16 bytes M through to M15 and fed to the round 1 after the initialization stage. So after the initialization stage, it is fed to the round 1. In this round, substitute unit S block perform the byte to byte substitution of the block. So this is called as S block. Here it will do some byte to byte substitution of the block. Then Cipher moves through a permutation stage. This is the permutation stage. After that, it is fed to one more stage, that is called as a mixed column stage. Here mixing of columns and rows are taking place. At the end of the 16th round, the ciphers are whatever at the end of the 16th round. So the ciphers are exclusive ORed with the 16 bytes of round 1 key, 16 bytes of round 1 key through round like 15 key 15. So it is exclusive ORed with the different rounds of key. So in order to provide the ciphertext. This is the working of advanced encryption standard. So in this video we have discussed what is DES and what is AES. So in the next video we will see what is the RSA or public key crypto system, and what are the benefits of a public key crypto system, how public key crypto system can be used for to generate the shared key or for confidentiality purpose or for authentication purpose. All these things we'll see in the next video. Thank you.